Hey, pre-calc students, it's me again. We're going to dive into 9-6. I want you to do me a favor before we begin. I need you to reread all of the geometrical definitions of each of our conic or quadratic relations. Okay? Please do that. Pause the video and do that. Alright? Also, I want you to take a look at these equations. Again, this is for an ellipse. I want you to look at these equations. We're ignoring the foci and stuff like that for now. I'm still probably going to cut it out. There's not enough time. Even right now, I'm trying to get this down to 15 minutes. But look again at these. These are important. Okay. Let me again definition. Reread it. Okay. And then again, look at these here. Okay, they're gonna play importance here in a moment. Okay, I'm gonna set things up here. Let me pause. Also, this is another good page to look at. Look at those again. Look at the coefficients. I talked about this already in previous videos, but take another look at this blue box equation. Okay, I have a little no off to the side, not NO, but KNOW. Okay, so know this. All right. Okay, so I'm already giving you guys the answers right here on, so you can already look at them. If you can zoom in or whatnot, if it shows up clear, you've got the answers. But I'm gonna work number 1, and then I think I'll sign number 2 or something. But again, it says to find a polynomial equation with integer coefficients for the set of coplanar points described. Tell whether or not the graph is a conic section. If it is, which one? Okay, so I'm gonna work number 1. All right. Okay, so in the instructions it says you're given 2 points, okay, -3, 0, and 3, 0. And I'm just making this up because I have no idea what this looks like, okay? So I have -3, 0, and 3, 0. And it says that the distance from these fixed point to a fixed point on the graph, this is double the distance of this. So I'm making this up, and it's not a straight line, but you know, it's easier to see here. So if I were to take this, it looks like half of it's there and then half of it's there. So this distance is double this. So if I called that distance D, then this distance would be 2D. Okay? So that's what we're given in this situation. So let me ask the question. How would I find a distance of a line like this? Okay? Physics students should be able to immediately see, oh yeah, if I want to find a distance between 2 points, that's pretty easy. I know that that's just going to be the distance formula. Okay? Okay, so you guessed it. The distance formula, or using the magnitude, the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Alright, so distance 1, I'm going to label that this one. This is distance 1. Okay, I'm using the point 0, 3. Alright, and then we want to know it from this point. We don't know this point. This is a point on the curve. This could be an ellipse. It could be a hyperbola. It could be something. I don't know. Or all I know is that maybe it's this. Okay, so I'm just call it xy. Alright, and so subbing in the parts where they belong, that's that one. And then distance 2, okay, using the point -3, 0, you can see that I have this. Okay. Whoops, 1 second. I labeled P1 this one, so that would be this one. Subtraction, so x minus minus is going to be plus. So subtraction of negative plus, and then y minus 0 here. And then this one here, x minus 3. And so, my apologies, I'm calling this one D1 and this one D2. Okay? But we're not done. I'm going to set up the next part. Okay, so I know that D, I don't know why I keep using lowercase and uppercase intermittently, but anyways, D1, this one, is twice D2, okay? So I'm going to set that F equal to there, and then twice D2. I've got this going on here, and again, my goal of this is to find the quadratic relation equation, okay? We want the equation for this quadratic relation. That's probably a better way to say it. Okay, I'm going to go ahead and simplify this down. I'm going to show all my step of this, so bear with me. You'll have to pause if you want to see the intermittent work, but I'm going to show it all in one. Okay, boom. Okay, it looks kind of scary here, but all this is just algebra. Okay, squaring both sides. Key to remember is when you square both sides, this is this whole quantity squared. So it's going to get rid of the square roots, but you have to remember to square the coefficient term out front. Okay. Now we're just adding like terms, so that's y squared and everything. Distributing the 4 to every single term here. Then we're going to get everything over to the other side to set equal to 0. All of these, I can factor out a negative 3. Hey, look, 27 divided by 3 is 9. I don't know why anyone would put anything different. Yeah, we'll just move on. So then simplifying, we get this. Okay, so in your graphing calculator in your conic section, you have that mode. Let me pause. Okay, so we have this mode here that if we want it from earlier with r squared, or you have this way. So if we take our equation down here, a is 1, okay, b is 1, okay, b is going to be the term in front of the y, okay, they need to make sure they match. C is going to be negative 10, and then d, there is no y term by itself. Then I'm going to go ahead and graph, and boom. I don't think that worked out. Pause. Okay, I know that didn't look like right there. So A is 1, B is negative 10, C is 0, and D is 9. My apologies there. And so we should get the graph to look like this. Okay? So you could also see from the other format. So taking this equation, and like we've been doing, we can stop here. This is the answer. But if you went and wanted to get into the format up here, into this format, the H and K format, you can see we've got that, factored that out. Put those terms in there, and then boom, the graph works out. It looks exactly the same as the one we had a moment ago. Okay, so there we go. Okay, so now take a look at number 5. Okay, so number 5 is saying each point is twice as far from the line x equals 3 as it is from the line y equals negative 2. Okay, ignore this a moment. Okay, I like to draw a sketch. This is what's going on. Okay, here is the line y equals negative 2. Here's the line x equals 3. And it says some point. So maybe there's a curve. Okay, so maybe there's a curve out here. So there's some fixed point. I'm going to call fixed point F. Okay, so there's some point out here. And it's saying that we are twice as far from this line, the x equals 3 line, as we are from here. Okay, so in other words, this line is double this. Okay, this distance here is double this. All right. Again, I'm using horizontal and vertical lines to try to make it easier. Okay, so this line here is double this. All right. So that's where the confusion in the setup is like, which one do you double? Well, if you draw a sketch, always helps. So this distance is double this. Okay. Now I have the point 3 comma y. I don't know this point here. I know that it's always going to be 3 and comma y, because it's the y value will always be the same. Or excuse me, the x value will always be the same. The y value can change, but it's always going to have the exact same x value. Over here, this is x comma negative 2. This will always have the same y value. Okay. Oops, I got focused on this one. It will always have the same y value. Okay, the x values can change. Okay, let me show the setup. Okay, so d1 equals 2d2. All right, and so I set that up here using distance formulas. Like, what? That's why getting the points is kind of nice. This is 3 comma y, and this is x comma negative 2. So then I can just plug those in wherever. So using the distance formulas from up above, using those. This is going to be nice because that's going to be 0 and that's going to be 0 there. These actually are easier in the sense that the algebra, but the setup is sometimes harder because like what are we even doing? Okay. Okay, again, squaring both sides, squared both sides. Don't forget to square the coefficient term. Adding like terms, simplify, setting equal to 0. This time I did it in descending order here so I can see this better. Different signs on the squared terms. This is going to be a hyperbola. And actually it's a degenerate hyperbola. It doesn't actually work out, but don't worry about that. I didn't ask you to simplify this to set it equal to 1 to graph. Okay, so we're just interested in getting the equation. That's the goal for today. Get the equation. Okay, this next one we're going to do is going to be an ellipse. The answer is an ellipse, but we're going to focus on the fact that D1 and D2 are the distances from point D on the ellipse to the two foci, then we have this information there. So, okay, so this one's a little bit easier. I'm jumping right in here. It says the foci are here, and then it says the major axis is 10. All right. Then remember, you have this equation, D1 plus D2 equals this. This one looks like, hey, this looks like it's almost set up for us already, like on a silver platter. Okay, length of the major axis is this. So 2 is going to be, or 2a is going to be 10. Okay, I'm going to show the setup. We're using the same thing. We're going to use the distance formula using these points and the distance formula using these points here. Okay, because it's the distance from the foci to the actual ellipse. Okay, so let me show the setup. Okay, so here's the setup using these points. So x minus 4 quantity squared plus y minus 0 quantity squared plus this equals 10. So there it is. The last step we need to do is just do the algebra. So I'm going to show all that work here in a moment. So again, D1, D2, and major axis. So if this is an ellipse, major axis, we don't know if it's along in the y or along in the x, but we do know that the length of that major axis is 10 units long. Okay, what a mess. All right, so we're at this point. We can't just square both sides to get rid of these square roots. Okay, that's no way, because you can't do that. You can't have square root of a plus square root of b equals 10 and then just square and get rid of the square roots. So I have to subtract this. This is way back in Algebra 2 last year. I have to subtract one of these two quantities. I chose this one, subtract it to the other side. Then I square. We're going to end up having to square both sides of this equation twice. I'm going to square once, subtracting this to the other side, square both sides. Simplify down. Okay, this is a monster to distribute here. You got those there, but use FOIL, folly, whatever, but distribution. Okay, this one's easy here. And then now we're going to get to the point where we're going to add like terms and set it equal to the square root side. Okay, so this is just algebra. Pause it if you need to. I'm going to continue on. Okay, still not done here, but this is a beautiful thing when we see x squared and x squared, and they become 0. That's a beautiful thing. Okay, so adding like terms, getting this, all of these terms are divisible by 4. So simplifying down here. Now we're at the point where we're going to square both sides. All right, so this right here is a beautiful part right here. Yay! Okay. Okay, so we're at this point here where we wanted to square both sides. We square both sides. We get this and this squared. Okay, so remember to square both sides. Adding like terms, simplifying. Hey, look at all those terms that cancel out and we get to this. All right, this is the answer we're looking for. I'm going to go ahead and take it one step further, but this is all we're required to do right here. Find the equation. Okay, so I took this equation, put it into our ellipse format, and our foci, if you remember, was at -4, 0, and 4, 0, and we've got this. The length of the major axis is 10 units long. 5 out this way, 5 out that way. Okay, so that should match this here. All right. Now, what in the world did we do? We set D1, did all this other stuff way up here. We said D1 plus D2 equals that. Well, let me pick up here and put it on here. Okay. So imagine that we had a string that was 10 units long, and we put pins at each of the foci. Put pins at equal to foci, and we stretched it out. We had a pencil here, and this string is attached with a pin between these two distances, so -4, 0, and 4, 0. All right, and the length of the string is 10 units long. We were to stretch it out, and as we move it around, okay, the distance, so right now maybe that's D1, D2 would be this other one here, okay? So, or if we stretched it, here's a different look here, so that would be D1 and that would be D2, okay? The length of the total string is 10 units long. So that's what we did. That's how we found this equation. All right. So that's all I have for today. And Lord bless and have a great day. All right. Bye.